Hello my dears, very good evening. It's actually afternoon, so very good evening all. So until the last class we discussed or we completed control system, electrical measurements, circuit theory and what? Okay, that's all right. So these are the very important subject my dears, and if you completely study this, I mean without missing any point in the syllabus, if you completely study these three subject, it's very important. That is machines, measurements, control system and circuit theory. Pakka, this four subject. Definitely more than 50% mark, not more than 50, 60% mark surely you can cover. Okay, rest of the syllabus will be small subjects are there, like digital electronics and signals and system. See, for that subject and all, they are very short subject. Also definitely you will get mark from that. For digital subject, easy question will be asked, but you have to cover everything. That's all. Okay, and that also not a vast subject, right? That also not a vast subject. And signals and system also some properties and something is there. We will discuss that, and bus, that's all. So now we are moving to a very important subject in electrical engineering. That's nothing but power system. It's some vast big subject, so it will take some time. Sometime in the sense I planned minimum 20 classes, right? 20 classes, maximum 20 classes, not minimum, maximum 20 classes. Within that I will finish it. So 20 classes means we will approximately take 20 days, that's all, 20 days. So before June 30 maximum, if possible I will complete the whole syllabus, and I am not sure that we can complete the previous year questions. Okay, my word was what? I promised you within 6 months of time I will complete everything, but the electrical inspectorate exam date suddenly came, so we will complete the syllabus surely, but for previous year question paper analysis we need more time. Okay, so examination point of view only I am taking the classes, my dear. So strictly according to the examination point of view. So, and I am not intend to deliver you in a very vast manner. For example, suppose the power plants, hydroelectric, nuclear, or thermal power plant, etc. It takes 2-3 hours of classes nearly. In university exam based classes, it takes normally 2 to 3 hours. But for our examination point of view, it is not that much needed. So only important points that I am going to discuss, and comparison, and some terminology is also there. So that also I am going to discuss now. So first of all, we have to learn some factors, my dears. Learn some factors. I hope you heard already load factor, diversity factor, distribution factor, like that one. So that factors we have to take care of, because definitely a short question will be asked from that factors. So we have to make sure that we are all aware of that. Okay, so before going into the factor concept, my dear, so let us consider a system, a power system. Suppose a power system is there. Suppose at Kottayam, consider city of Kottayam. It have a mole. Suppose you assume a mole. Mole need 1500 kilowatt of power. Just assume. And another is cinema hall or theatre. It needs 1000 kilowatt. It's just an example. Okay, it's just an example, my dear. Not this much, or it may be very, or it may be very differ. Okay, and another auditorium. Suppose auditorium, it requires a 800 kilowatt. Another a factory, suppose a factory is there, it requires 4000 kilowatt or 4 megawatt, simply 4000 kilowatt or 4 megawatt. So this is the simple distribution diagram of a Kottayam city. So what is the maximum demand of the substation which is situated in the Kottayam city? Substation is also be considered as the small generating station, not in the sense of it generate energy, but it is a station from which we are taking energy now. So it can be considered as a small generating station. Okay. So what is the maximum demand to this Kottayam substation or Kottayam generating station? What is the maximum demand? The maximum demand is nothing but, my dears, 4000. That is the maximum demand. So the generating station in the Kottayam should deliver more than this, then only a maximum demand can be met. Suppose the Kottayam generating station is delivering only 3000 kilowatt, means this factory doesn't work. So always take care of one thing. For set up a generating station, you should note one thing, that the maximum demand of the load should be met. Okay, that is the maximum demand concept. And these all are the individual maximum demands. Suppose the auditorium needs 800, means it is its maximum demand, that auditorium demand. Theatre means 1000 kilowatt, means it's its maximum demand. And all, if you add it together, this is called the sum of the individual maximum demands. Sum of the individual maximum demand. Okay. Now we will move to certain factors, my dear, certain factors. First one is, what is a load? What is a load? What is a load in power system? A load in power system can be easily say that the thing or the element which absorb I or P is called a load, is called a symbol. Any element or anything which absorb current or in simply power is called a load. Next, you have to say some factors. You have to mention about some factor. First one is load factor, LF. Load factor is nothing but, my dear, it is the ratio of average load divided by maximum demand. Average load divided by maximum demand. Average load means simply what? Average load means what? Average load means, what is the average load here? 1 plus 2 plus 3 plus 4 loads are there. Simply add and divide by 4 will be the average load. That's all. So average load divided by maximum demand is called the load factor. And always its value will be less than 1. Always its value will be less than 1. But you have to make sure that the load factor should be always high. High in the sense 0.9, 0.8, 0.95, 0.98, etc. You have to note it down. Okay. Next one, demand factor. Demand factor and DF. Demand factor means it is the ratio of maximum demand divided by connected load. Maximum demand divided by connected load. So for this Kottayam generating station, what is the maximum demand? 4000. What is this connected load means? The sum of the whole loads, that is called the connected load. Okay, that is called the demand factor. Its value also will be less than 1, surely. Its value also less than 1. Okay, and another factor you have to note, another important factor is that utilization factor. utilization factor. So utilization factor means maximum demand divided by system capacity. Maximum demand divided by system capacity. Maximum demand divided by system capacity. Its value also maximum demand divided by system capacity. Its value will be also less than, because system capacity should be greater than maximum demand, right? So its value should be less than 1. Its value also less than. Next factor you have to note is that planned capacity factor. Planned capacity factor, PCF, which is nothing but, my dear, utilization factor into load factor. Planned capacity factor is nothing but, my dear, utilization factor into load factor. Utilization factor into load factor. So next one, very, very important, diversity factor. Not short form, diversity factors, okay, which is nothing but sum of individual maximum demand whole divided by maximum demand of the power station. Listen, my dear, its value only greater than 1. Diversity factor is the value is always greater than 1. Its value is always greater than 1. Sum of the individual maximum demand divided by maximum demand of the power station, because sum of the individual maximum demand means, suppose there are 100 loads, you assume, each having certain maximum demand, right? So if you add it is together, it will be greater than the maximum demand of the power station. Of course it will be greater than the maximum demand of the power station, sure, because we are assuming in a manner that, okay, I will discuss in when this problem came, we will discuss later. Okay, your worry will be cleared then. Okay, next one, coincident factor. Coincident factor, and its value will be nothing but, my dear, 1 divided by diversity factor. What is that? 1 divided by diversity factor is called the what? Coincident factor. So, and you add one thing, for economical operation of power system, load factor as well as this diversity factor should be high as possible. That also you have to note. For economical operation, the value of load factor as well as the diversity factor should be high as possible. Okay, should be high. Okay, so we will go to solve some problems regarding these factors. I know these factors now, in order to remember this factor is very difficult. I know that, because even if you remember for today, after 2 weeks you will definitely forget 2-3 things. After 1 month you will definitely forget everything. That's sure. So what is the trick is that you have to continuously revise it. You have to continuously revise this and make what? A strong memory of these factors, because this is very, very important. There will be definitely a question regarding these factors, my dears. So please take care of these factors. Okay, please take care of these factors. So let us do a problem so that it will be more and more clear. Okay, write a question. Write a question, my dears. A generating station has maximum demand of 25 megawatt, comma, load factor equal to 60%, full stop. Plant capacity factor equal to 50%. Find the reserve capacity of plant. How can we do this, my dears? See, a generating station has maximum demand of 25 megawatt. Load factor is given, plant capacity factor is also given. Find the reserve capacity of the plant. This is our question. How can we proceed? See, this type of question will be asked for your examination. This type of question will be asked for your examination. How can we do this? How can we do this? How can we do this, my dears? So, reserve capacity is nothing but, my dears, reserve capacity. It is nothing but plant capacity minus maximum demand. Reserve capacity is nothing but plant capacity minus maximum demand. Maximum demand is given, right? So, our aim is to find what? Plant capacity. This is our aim. This is our aim, to find the plant capacity. Okay. Is it clear? Is it clear, my dear? So plant capacity you have to find. You have to find. So what are the equation which connecting the plant capacity? That you have to bring to your mind. So plant capacity, what equation that we connecting the, or that includes the plant capacity? Right? Think of that. Think of that. Plant capacity, what equation? What equation, my dear? What equation? See, utilization factor. You remember this? Utilization factor. Utilization factor will be equal to maximum demand divided by plant capacity or system capacity. Am I right, my dear? Am I right? Utilization factor. But maximum demand is given, plant capacity we have to find. Utilization factor is not there. Am I right? Utilization factor is not there. But is there anything which is connecting the utilization factor and plant capacity factor? Yes. What is plant capacity factor? Plant capacity factor. What is that? Which is nothing but utilization factor into load factor. Am I right, my dears? Am I right? Load factor. But load factor, is that given? Yes, it is given. Utilization factor, we need. Plant capacity factor, it's given. So I can simply substitute 0.5 is equal to utilization factor into load factor is 0.6. Okay, 0.6. For simplicity, you can take, wait, utilization factor will be equal to 0.5 by 0.6. Simply 5 by 6, my dear. Simply 5 by 6. So you got the value of what? Utilization factor. If you know the value of utilization factor, you can substitute here. So what will be the plant capacity, my dears? Plant capacity will be equal to maximum demand divided by what? Utilization factor. Maximum demand is given na 25 into 10 raised to 6 megawatt na. So utilization factor, my dear, utilization factor is given 5 by 6. 5 by 6. So 25 into 6 means what? 150 na. 150 into 10 raised to 6 divided by 5. So 5 into 3. So 30 megawatt. That is the plant capacity. So in your hand now everything, plant capacity is there, maximum demand is also there. So simply you can find the reserve capacity. Reserve capacity, substitute plant capacity minus maximum demand. 5 megawatt is the answer. 5 megawatt is the answer. So in order to solve this type of problem, my dear, what is we have to find? The reserve capacity. First write down that equation. Count the unknowns there. And see the question again. Is there anything which connecting that unknowns? Find it down, find it down, find it down. Step by step procedure. And finally go again back to the equation. You will get the answer. You will get the answer. That is how we have to solve this question in this factors concept, right? Factors concept. Is it clear, my dears? Is it clear? Next question. This type of questions are very, very popular. Now it's beautiful, right? Okay. Calculate energy consumed, comma, maximum demand, comma, load factor. This type of questions are very, very popular, my dears. First of all, calculate the energy consumed, my dears. Energy consumed. So energy consumed is nothing but, it is nothing but, my dear, kilowatt hour. Total kilowatt hour is nothing but the energy consumed. So there are 5 megawatt of load for 8 hours. So I can simply like 5 megawatt of load, kilowatt hour is you needed, right? Kilowatt hour you needed. That you have to multiply the power in kilowatt with hour, right? So 5 megawatt means, I can say that 5 megawatt means 5 into 10 raised to 3 kilowatt. Am I right, my dears? So 5 into 10 raised to 3 kilowatt, and that too for what? 8 hours. Am I right? And next, 10 megawatt for what? 10 megawatt of energy for again from 8 to 16. 10 megawatt from, see, it is very easy, my dear, I will tell you. 5 megawatt of energy, where it is used, you just remember this. 5 megawatt of energy array from here to here. Here to here means total hours is nothing but 16 to 24, it is nothing but 8. That is why this 8. Next one, 10 kilowatt hour. For how many hours it is used? 10 kilowatt hour from here to here it is utilizing. 10 kilowatt from here to here means again 8 to 16, 8 hour. So I can say again say it's 10 into 10 raised to 3 into 8 plus 15 for again 0 to 8 hour. So 15 into, that is the total kilowatt hour. That is the total kilowatt. So it will be 40 and 80 and 120. So it will be 40, 120, 140. (240 into 10 raised to 3 kilowatt hour, my dears. 240 into 10 raised to 3 kilowatt hour. Okay, so you got the energy now. So maximum demand, what is maximum demand? It is already given. Maximum demand means maximum demand is 15 megawatt. That's all. No need of calculation or anything. Next one, load factor. Average load divided by maximum demand. Average load divided by maximum demand. We don't have average load now, right? You don't have average load now. You can take average load as what? You can take average 10 plus 5 plus 15 divided by 24. 5 plus 10 plus 15 divided by 3, right? That will be the average load. But I am using another thing. I am going to multiply into T and into T on both sides, numerator as well as denominator. So average load into time will be nothing but, my dears, energy consumed. Average load into time is nothing but energy consumed. Because I want to introduce something new now, that's why I multiplied. So always, if there is, if someone somewhere you stuck, so average load into time will give you the energy, total energy consumed, divided by maximum demand into time. Maximum demand into time. Here time is nothing but the total time now, 24 hour of operation. So energy consumed you already have 240 into 10 raised to 3 divided by energy in kilowatt hour na kilowatt. So maximum demand in kilowatt hour means 15 into 10 raised to 3 into 20. So 10 by 15. So 10 by 15 is nothing but, my dear, 2 by 3. 10 by 15 means 2 by 3. So that is the load factor. See, the load factor is less than 1 now. The load factor is less than 1, okay. The load factor is less than 1. That's all. That's all. You can take in this manner also, that also, right? See, simply without multiplying this, you can take this manner also. Simply average load divided by maximum demand. Let's check both are same or not. Let's check. I want to introduce a new term, that is why I use this equation. You can directly go for average load by maximum demand. Average load nothing but add this 3 divided by 3 will give you the average load. 15 plus 5, 20, 20 plus 10, 30, 30 divided by 3, 10 divided by maximum demand is nothing but 15 megawatt. 10 by 15 again, or 2 by 3. This same, both are same, my dear, both are same. No issue. So you have learned a new thing, right? That's why. This is very, very important, my dear. Many times I faced a very good help. I faced a help from this equation many times. I stuck when I am doing problems. So suddenly average energy will be equal to what? Average load to time. Okay, I got the energy. So many time, many situation I utilized this. That is why I am saying it's very, very important. It's very, very important. Is it clear, my dears? Is it clear? I can't do every problem regarding these factors, my dears, because numerous problems are there. So there is no time for doing every problems, but some problems you can, which commonly you see in the competitive examination, you will discuss. It's given plant capacity 750 megawatt. You have to find utilization factor, load factor, plant capacity factor, maximum demand, and reserve capacity. Everything you have to find. Everything you have to find, my dears. Everything you have to find. Everything you have to find. See. So, okay. So plant capacity is 750 megawatt. So what is the maximum? I'm not doing this order. Can do any order now. So see, my dears, plant capacity is 750 megawatt. What is the maximum demand here? Maximum demand here equal to, maximum demand here equal to 500 megawatt. Am I right? It's given now. It's given. So I can go for the reserve capacity, my dear. I can go for the reserve capacity directly. Plant capacity minus maximum demand. So plant capacity is given now, which is that plant capacity is 750 megawatt. Reserve capacity, sorry, maximum demand is given now 500 megawatt. So reserve capacity will be 50 megawatt. That's it. Reserve capacity will be what, my dear? 250 megawatt. Yes, right. That's right. Next, load factor. Let's go for load factor. Load factor equal to, load factor equal to, what is that, my dear? Average load divided by maximum demand. See, my dears, is that average load is directly given? Is that average load is directly given? No. But how can we calculate the average load now? Can we calculate the average load now? Of course, it's a straight line, right? It's straight line, right? So average value is nothing but, my dear, just to simply add this 2 divided by 2, that's all. Average value is nothing but 400 megawatt for some time, 500 megawatt for another some time. So simply add these megawatts, divided by 2 will be the average power, simple. So I can say like minimum plus maximum by 2 will be the average load. 4 divided by maximum demand. Maximum demand is 500 megawatt. So it will be equal to minimum 400 plus 500 megawatt whole by 2 whole divided by 500 megawatt. So the answer will be, my dears, 5 4 9 2 450 megawatt, right? 450 megawatt divided by 500. 0.9 will be the load factor. 0.9 will be the load factor. Is it clear, my dear? Next one, what is utilization factor now? What is utilization factor? What is that? Utilization factor. Maximum demand divided by plant capacity. Am I right, my dear? So maximum demand is given, right? 500. Plant capacity right now 700. Five by 6. So utilization factor is nothing but, my dear, 10 by 15. So 10 by 15, 2 by 3. 2 by 3 utilization factor. Any order you can calculate, my dear. Any order you can do. Not it is exactly in the order of the question. You can do in any order. And what is the final? What is the final thing? Plant capacity factor, right? Plant capacity factor is nothing but, my dear, utilization factor into load factor. Everything is directly given. That's why I did earlier. 2 by 3. Load factor, what value you got, my dears? Load factor 0.9, na? 0.9, right? 9 by 10, correct, na? .6. That's how we have to solve this type of problems. That's how we have to solve these type of problems. Is it clear, my dears? Is it clear? Is there any doubt you can ask? Is there any doubt you can mention in the comment section? Is there any doubt you can mention in the comment section? And also you have to by heart one thing, my dear. Hours in a year. Hours in a year is nothing but there are 365 days. Each day continue 24 hours. So it will give you 8760 hour. By heart this, my dears. By heart this. Many cases you can utilize this. Many cases you can utilize. Suppose you are calculating these factors for a year. Definitely it will be very, very helpful. Okay, that's all. Next one, power plants. Power plants. First of all, that hydroelectric power plant. In Kerala, we mostly depend upon hydroelectric power plant. That's why now this is a very hot season and the level of water in the dam declined. So power cuts frequent, right? Power cuts are frequent nowadays. So that's why, because we are depending more on hydroelectric power plant, EDK substation, right? EDK generating station we are mostly dependent upon. That's why these problems are coming, right? When come to North Indian side, all India, greater than 60% of the power, nearly 70% of the power is from thermal power plant. So the coal price that mostly affect the thermal power plant, and the rate per unit charge of thermal is very high, because we are living in a very city in North India, and in our hometown it's Palakkad, no? So in Palakkad per unit charge will be nearly 5 to 6 rupees maximum, 5 to 6. But there in city in North India, it approximately 10 rupees per unit. See the difference. See the difference. That's why. So So thermal power plants are very costly actually, very costly, because coal price na, it is a non-renewable energy, right? Coal, that's why. So I am going to discuss very few things about hydroelectric power plant, my dear, because from childhood itself you heard the word hydraulic and how this energy is generated, and you know this, I know, you know this. But the kinetic energy, the potential energy of the water is created by storing it in a dam, and by releasing it, the potential energy converted into the kinetic energy, and the water hits on the turbine or the turbine blades, and the turbine rotate. The turbine is connected to a generator, so the generator also rotates, so energy will be created, that's all. Not created, so energy will be transformed. Each word is very, very important, right? Created means energy cannot be created, right? It can be only be transformed from one form to another. So the kinetic energy, so the potential energy of water is converted into the electric energy in hydroelectric power system. So I can say that potential energy of water converted into what? Electric energy. That is happening in the hydroelectric power plants. So you know these very important terms and all. Okay, and the hydroelectric power plants, my dear, construction is very actually construction time is very high in hydroelectric power plant. Construction time, nearly 8 to 10 years you need to construct a hydroelectric power plant, not what thermal power plant this much or nuclear power plant this much. Only hydroelectric power plant required very many years, nearly 8 to 10 years for the construction. Okay, and the capital cost is very high, my dears. Capital cost is very high. Capital cost is very high. And I am going to discuss a few words regarding this hydraulic power plant that you are likely to be unfamiliar. That is nothing but track crash, not a track crash, it is trash rack. Did you heard this before? Trash rack. So my dears, trash rack is used to remove debris in the sense sand, wood pieces, plant pieces, stones, etc. These all are debris. Debris means waste, some unwanted things. So in hydroelectric power plant, what we are going, this is the dam. There will be huge pipes called penstocks. Okay, huge pipe name is penstock, and this is our powerhouse. There turbine will be there. So this water hit into the turbine, and the turbine will rotate, and the turbine is coupled to generator. That's a simple diagram. So there will be a tank called surge tank. I will tell you now what is the purpose of surge tank. I will tell you. So from the dam, my dear, the dam here no, dam contain everything, every waste, every material. No, we can't predict what dam contains. So the water in the dam contain. So now here we are using a trash rack here. So by trash rack, after trash rack, the water is moving to this penstock, so that the water is clear. Devoid of any waste material. Suppose these waste materials are moving, my dears, it will what? Strike the turbine blades, and the blade may damage. For avoiding that, we are using a trash rack. It's a very new term, that's why I mentioned. And other thing, tail race. Did you heard the word tail race? Did you heard the word tail race? Tail race is nothing but, my dear, here the water is hitting, right? Here the water is hitting, right? After that, where this water going? Where this water going? Where this water going? The path of the water after hitting, you write it down. Okay, I'm not going to write everything. The path of the water after hitting the turbine blades is called the tail race. Tail means atom, valid atom. Tail race. The path of the water after hitting the turbine blade is called the tail race. These are the tail race. These are the tail race. Okay. Next one, very very important term, my dear. Surge tank. It's very very important term in hydraulic power plant. Surge tank. What is the purpose of tank? So once I am going to draw this penstock. Powerhouse. Okay, you can simply like this. Turbine, alternator, powerhouse. Powerhouse. Okay, this is turbine. So my dear, here it is, we are using a surge tank. Surge tank. The purpose of surge tank, actually the serve main two functions. First one controls the flow of water. That means when there is a huge demand of load in the load side, my dears, the load side, we need more water, or in another sense, suppose in the load side, if you need more load, means the alternator speed should be very high, right? The alternator speed can be very high only if the turbine is rotating very fastly. The turbine is rotating very fastly only if the water hit it very speed, or more water come to contact with the blade, then only the turbine rotates very fastly. So whenever there is a sudden load change, we can't adjust the inflow of the dam. Okay, what dam is open, dam is closed, dam is open, dam is closed. That is not practically possible. So what we are going to do, we created a very big tank. This surge tank is not a simple like a 500 liter dam, or the 500 liter tank, or simply the tank which is used in your home now, in the roof of the home, right? 1000 liter, not like that. It may be very very high liters capacity tank. So that tank is used now. And what is the function of the dam, I mean surge tank, is that under very load condition, when load is less, the water is continuously flowing, right? We cannot intermittently we cannot do anything with the flow of the dam's outlet. Okay, it can be only up once in a period, or 6 months or 3 months or 4 months only we can adjust the outward flow. So suppose the load is suddenly dropped, we don't much require this high speed, right, at that load time. The load is increased, so the alternative need not be run very fastly, right? So it is low load, right? So the alternative speed should be very low. Only that load speed is needed. So the turbine speed also should be very low. So what we have to do, the water which is coming here now, it goes into the surge tank. it goes into the surge tank. And the surge tank start filling. The surge tank start filling. Okay. So load decreases means water flows to surge tank. Okay. When load increases, what happens? Water flows from the surge tank to turbine. So after some time suddenly the load increased means the sensors will sense the load capacity, and suddenly the load increased means what happened? There is a sensor which senses, and there will be an open of the surge tank happens, so that the stored water now it will completely, it started discharging through this area, so that suddenly the turbine gets the high speed. Suppose here we are increasing the speed, increasing the outlet means when it reach him here means it is from meters and meters, 300 meter, 400 meter long pipes are these, right? So suddenly the load increasing means we don't have to control these. We can't control this because it takes so much time to control this and reach here. But control this is very easy. So if you simply open the surge tank means water will be flow very rapidly to the blades of the turbine, and the turbine rotate very fastly, so that the load demand can be met very fastly. Okay, is it clear? And suppose again the load is decreased means again it will be closed, or the opening of the surge tank can be adjusted, so that the more water will go to surge tank. That's all. And the second purpose is that it reduce water hammering. My dears, very important term and very interesting term also. Water hammering. Hammer means nothing but chuttiga, right? Chuttiga. Water hammering means, suppose we are controlling from here the water bubbles, right? The water bubbles or water droplets now, it have a very high kinetic energy, so that it will suddenly hit, or it will hit the blades with a huge force, my dears. It will hit the blade with a huge force, so that the blades may bend, the blades may break, or the blade may deteriorate slowly. So for avoiding that, the surge tank is used. That means whenever the load is increased, no problem, the surge tank will take care, so that from here to here the water is flowing, or from here to here the water flowing impact the blade more. Which impact the blade more? From here to here the water flowing impact the blade more, my dears, and not from here to here, so that the impact on the blade can be enormously reduced if you are using a surge tank. That's all. Is it clear? Is it clear, my dears? Is it clear? Okay, so that are the functions of a surge tank. Okay, that's all about the terms or terminologies related to the hydraulic power, but rest of all I know that. I don't want to much more. In fact, it is actually not in your syllabus also, but there is a chance to ask some question. That's why. Next one, classification of turbines. Classification of turbine, and which is on basis of the type of flow. Based on the type of flow. First one, axial flow. Second one, inverter radial flow. Third one, tangential flow. Fourth one, mixed flow. Axial flow means the water flows actually. Kaplan turbine is an example of axial flow turbine. Just remember these words, my dear. Just remember these words, that's all. Inward radial flow turbine. Water flows radially into the turbine. And tangential flow turbine. Again, water flow tangentially, you know this. Example, Pelton wheel. You know, heard that? Pelton wheel. Pelton wheel. And mixed flow means both tangential, that means inward flow will be radial and outward flow will be axial. Example, Francis turbine. Just to note this, just by heart this, that's all. No need to much move into this because it's not that much important, that's why. Francis turbine, tangential, inward radial flow, we don't have any example. Okay, that's all. Next one. According to head. According to head means according to height, my dear, head or height. First one, low head, medium, high head. Low head means nothing but, my dear, less than 30 meter. Medium means 30 to 300 meter. High means that to that 100 meter. High head is Pelton wheel. Low head is Kaplan. And this is Francis. Just to remember this word, my dear, that's all. Just remember these words, that's all. So that's all about today's session, my dear. Okay, so let's meet again tomorrow with a new session. So until then, bye, take care.